Yes, my dear students. So, my name is Lakshmi Narayana. Today, we are going to discuss ionic equilibrium topic. So, previous we are discussed about the chemical equilibrium. So, nothing but what is the equilibrium constant, how the reaction is established in the equilibrium, then how many types of equilibriums are present, then later some of the problems, numerical problems on calculate Kc. So that we are discussing. So now we are going to discuss ionic equilibrium. Ionic equilibrium. Sir, what is the ionic equilibrium? So before going to discussion about the ionic equilibrium, what is the ionic equilibrium we have to discuss. Sir, what is the ionic equilibrium? Means here first one of the compound we are taking, that is, so just assume it AB, one of the compound. It is dissociated into A plus B minus, A plus B minus, like that it will be dissociated. So these are we are calling ions. These are we are calling ions. So one is positive ion, one is negative ion, like this. So now we are calling it is molecule. Molecule. So these ions are again they are combined to come back formed as AB, like this. Sir, once forward and backward reaction both are takes place, such type of reactions we are calling equilibrium reactions, we know that. So now ions are equilibrium with a molecule, or molecule equilibrium with the ions. Such type of reactions, ionic equilibrium, because ions are involved in the reaction, so that is why we are taking this. So now so which type of ions actually will be formed in the chemical reactions, sir? Sir, for example, CH3 COOH, that will be converted into CH3 COO minus plus H plus, CH3 COO minus plus H plus. Sir, here it is a weak electrolyte, we call it as a weak acid, weak acid. Sir, weak acid, so not complete ionization takes place, so that is why you are calling weak acid. Sir, chemical substances are classified into two types based on passing of electricity. Two types. So one is electrolytes. So number two, non-electrolytes. Electrolytes and non-electrolytes. So dear students, electrolytes are again divided into two types. Sir, electrolytes nothing but the substances which is allowed to pass electricity through them. Such type of substances we are calling electrolytes. So which are the non-electrolytes? Non-electrolytes nothing but the substances which are not allowing current through them, electricity through them. Such type of compounds we are calling non-electrolytes. So now electrolytes are divided into two types, I told. Electrolytes are divided into two types. Sir, what are those? Sir, chemical substances are two types I told, that is electrolytes and non-electrolytes. Now I am telling that electrolytes are two types. So one is weak electrolyte. Another one is strong electrolyte. Weak electrolyte and strong electrolyte. Sir, what are the weak electrolytes? Sir, weak electrolytes nothing but 100% ionization does not takes place. Such type of compounds we are calling weak electrolytes. Sir, strong electrolytes, these substances are 100% ionization takes place. Ionization takes place. Sir, which are 100% ionization takes place? Sir, strong electrolytes are ionization takes place. For example, if you take HCl, it can be dissociated into H plus Cl minus. Complete ionization takes place. So, such as we are calling strong electrolyte. So, for strong electrolytes, degree of dissociation is equals to 1. What about the weak electrolytes? Weak electrolytes degree of dissociation is less than 1. That is maybe 0.2, 0.3, 0.4, 0.5, 0.6 up to the 0.8 and 0.9 also. That are weak electrolytes. Weak electrolytes nothing but some extent only can be ionized, not complete, not 100%. Such type of substances we are calling weak electrolytes. Sir, which are complete ionization takes place, 100% ionization takes place, then degree of dissociation is equals to 1. That are we are calling strong electrolytes. Sir, strong electrolytes nothing but what? And weak electrolytes nothing but what are the examples for that? Which are will come under the strong electrolytes? Which substances are will come under the weak electrolytes? That we have to discuss now. Sir, first if we take about the strong electrolytes. Sir, what are the strong electrolytes? What are the strong electrolytes? Strong electrolytes. Sir, under the strong electrolyte, sir, already we are discussed, that is 100% ionization takes place. 100% ionization takes place. Then one more thing I told, degree of dissociation is equals to 1. Such type of substances as we are calling strong electrolytes. Strong electrolytes degree of dissociation equals to 1. 100% ionization takes place. Okay, right. Sir, which are will come under that? So, for example, sir, number 1, all strong acids. All strong acids. Sir, which are the strong acids? For example, HCl, H2SO4, HNO3, then HClO4, HClO3. These all are will come strong acids. So all these strong acids are strong electrolytes only because 100% ionization takes place. Then second one, all strong bases. All strong bases. Sir, what are the strong bases? Sir, first group of the elements, all first group of metal hydroxides and as well as barium hydroxide, strontium hydroxide, magnesium hydroxide, these all are will come under the strong electrolytes. They are all first group of metallic hydroxides, nothing but what? Sir, NaOH, then KOH, then RbOH, then CSOH. Sir, all these are strong bases. Okay, right. Sir, strong acids will come, strong bases will come under these. The next third one, almost all salts are will come under the strong electrolytes. Sir, what are those strong salts? Sir, which are? Sir, for example, NaCl, then NH4Cl, then CH3COONa. These all are salts. NaCl, NH4Cl, CH3COONa. Sir, salts are formed from one acid and one base. Right. So all these are strong electrolytes. So remember that ionic equilibrium is not applicable for strong electrolytes. Why? What is the reason? Because these are 100% ionization takes place. Once complete dissociation takes place, ions does not converted into product again. Ions does not converted into compound again. So that is why strong electrolytes are not applicable to the ionic equilibrium. Then weak electrolytes are applicable to the ionic equilibrium. Sir, what are those weak electrolytes? Which are the weak electrolytes? That we have to discuss. So now weak electrolytes. So which are will come under the weak electrolytes? Weak acids and weak bases. Sir, what are the weak acids? Sir, first one, weak acids. Sir, what are the weak acids? Sir, remember that all organic carboxylic acids, such as HCOOH, CH3COOH, C6H5COOH, all these are weak acids. All these are what? Weak acids. So next, one more thing we can say, that is, for example, all phosphorus, oxo acids such as H3PO3, H3PO4, H3PO2, all these are what we are calling phosphorus oxo acids are weak acids only. Weak acids. And that then chlorine oxo acids. Sir, chlorine oxo acids, so in that HClO, comma HClO2, these two are HClO and HClO2, these two are weak acids. Sir, HClO3 and HClO4 are strong acids. Strong acids, these are weak acids. So weak acids will come under the weak electrolytes. Then next, sir, in case if you take nitrogen oxo acids, which are nitrogen oxo acids, that is third one, sorry, fourth one, nitrogen oxo acids. Nitrogen oxo acids are, sir, what are those? Actually nitrogen oxo acids are two are there, such as HNO2, then HNO3. We have discussed already about the HNO3. It is a strong acid. Then this is weak acid. That's it. So first one is weak acid, second one is strong acid. Even oxo acids of sulfur also is there. So that is fifth one, oxo acids of sulfur. Oxo acids of sulfur. H2SO3, H2SO4 is there. H2SO3, H2SO4. Here H2SO4 is a strong acid, we know that. H2SO3 is a weak acid. Understand, my dear students? Sir, these will come under the weak electrolytes. Sir, weak electrolytes degree of ionization or degree of dissociation, it is less than 1. It is very, very important. Less than 1. Okay, right? Okay. So less than 1, nothing but what, sir? In case if you take one molecule is ionizing, that one molecule not completely ionized, some of the percentage only it is ionized, that only we are calling less than 1. Okay, right? So now all the acids only we are discussed. All organic carboxylic acids are weak electrolytes, are weak acids. Phosphorus oxo acids are weak acids. Chlorine oxo acids are weak acids. Nitrogen oxo acids are weak acids. So in that nitrogen oxo acids, one is weak acid, one is strong acid. So chlorine oxo acids, 2 are weak acids, then remaining 2 are strong acids. Oxo acids of sulfur, H2SO4, no doubt at all, strong acid. H2SO3, weak acid. Then these all are, what I told, degree of dissociation or degree of ionization is less than 1. So less than 1, nothing but these are reversible reactions that takes place. Sir, for example, in case if you take CH3COOH, it can be complete into CH3COO minus plus H plus is formed. Then again these ions are converted into compound. So ions and compound both are present in the equilibrium. A compound or molecule which is equilibrium with ions, or ions are equilibrium with compound, that is molecule. Such type of reactions we are calling ionic equilibrium reactions. So these all the acids, these all are weak acids, establish equilibrium with ions. That is the reason we are discussing about this. Ionic equilibrium is applicable for weak electrolytes only. Not only for weak acids, even weak bases also will come under that. So what are the weak bases, even that also we will discuss. Second one is what? Weak bases. Sir, what will come under the weak bases? Weak bases. Sir, such as weak bases are NH4OH, ammonium hydroxide. Then a CaOH taken twice, calcium hydroxide. Then BeOH taken twice, beryllium hydroxide. Then FeOH taken twice, AlOH taken thrice, FeOH taken thrice. These all are weak bases. So weak bases, complete ionization does not take place. Understand, I think. So now we are going to discuss about, to explain about acid bases, to explain about the acid base characteristics. Then three theories are there to explain about the acid and base. Three theories are there. So what are those? That only we are discussing in this chapter. First, that is Arrhenious acid base theory. Arrhenious acid base theory. Sir, what is the Arrhenious acid base theory? According to Arrhenious, which is we are calling acid, which is we are calling base, that we are going to discuss. Sir, acid, first of all, what is the acid according to Arrhenious? What is the acid according to Arrhenious? Sir, simply that is Arrhenious acid, nothing but the substance which can give H plus ions in aqueous solution are called acids. The substance which can give H plus ions, in their aqueous solution we are calling. Sir, for example, if you take, sir, HCl gives rise to H plus Cl minus. So this HCl, it is when dissociated in the aqueous solution, it gives H plus ions minus Cl minus ions. So that is why it is acid according to Arrhenious. Sir, H2SO4, then 2 H plus ions can be released plus SO4 minus 2. Sir, HNO3 also can release H plus NO3 minus. Sir, all these are what we are calling acids. Then what is the base according to Arrhenious? Sir, base nothing but the substance which can release OH minus ions in their aqueous solution. The substance which can release or which can gives OH minus ions in their aqueous solution is called base. Sir, for example NaOH, on their aqueous solution it can be dissociate Na plus OH minus ions. So OH minus ions. CaOH taken twice, then Ca plus 2 plus 2 OH minus ions, it can release 2 OH minus ions. So the substance which can release OH minus ions we are calling base according to Arrhenious. So then what is the neutralization according to Arrhenious? So neutralization nothing but, sir, H plus and OH minus ions, when both are reacting to form H2O, that we are calling neutralization. So neutralization nothing but, sir, acid can release H plus ions. Yes. Acid can release H plus ions. It is acid. Then base can release OH minus ions. It is a base. Then both combined, both can react to form H2O. That is formation of H2O from H plus and OH minus ions is called as what? Neutralization. So this is about the Arrhenious acid base theory. So then what are the limitations of Arrhenious acid base theory? What are the limitations of Arrhenious acid base theory? What are the limitations of Arrhenious acid base theory? Arrhenious acid base theory. Sir, number one limitation in this, sir, it does not explain acidic nature of BF3, AlCl3 like this. Acidic nature of BF3 and AlCl3. These two are, if you observe, these two are do not having any H plus ions. So, but both are acting as acids. So, that is why it does not explain the acidic nature of what BF3 and AlCl3. So, it is one of the limitation of Arrhenious acid base theory. Then second one, it does not explain basic nature of ammonia. Basic nature of ammonia, NH3. Basic nature of ammonia. So these are the limitations of Arrhenious acid base theory. Now we are going to discuss about Bronsted-Lowry acid base theory. Bronsted-Lowry acid base theory. Sir, what is the Bronsted-Lowry acid base theory? Bronsted-Lowry acid base theory. Sir, what is it? According to Bronsted, so what is the acid? What is the acid? Then what is the base? What is the base? Sir, simply acid nothing but according to Bronsted, proton donor is called as acid. Proton donor is called as acid. The substance which has tendency to donate a proton is called acid. According to Bronsted, the substance which can donate a proton is called as acid. Sir, proton nothing but H plus ion only, which can donate proton to proton acceptors. So that is we are calling acid. Sir, what is the base? Sir, base is opposite to the acid. Sir, here proton donor I told, here proton acceptor. Proton acceptor. So the definition we can say that is the substance which can proton is called base. So now, how can you explain it is which is the acid and which is the base according to Bronsted and Bronsted base? So Arrhenious concept, they are telling that is which can donate H plus, which can give H plus ions in the aqueous solution, which can give OH minus ions in their aqueous solution. But here it is a different case. One is proton is donating, one more proton is accepting. So this happens in between the both chemical reactions. Sir, for example, if you take HCl when reacts with H2O, then, sir, here HCl is an acid. HCl is an acid. It is donating proton to this. Then H2O that is converted into H3O plus, then plus, then H3O plus, then here Cl minus will be formed. Sir, here proton is donating, so that's why we are calling acid. Then here proton is accepting, so that is why we are calling it as base. Then it is in the forward reaction. In case if you come the backward, sir, here H3O plus is donating to H plus ion, which is H plus in the backward reaction. So that is the reason Cl minus again converted into HCl. So here Cl minus what it is doing? H plus is accepting. So H plus ions accepting, nothing but proton acceptor is called as what? Base. So Cl minus is base here. It is acid here. Acid and base. Sir, in a reversible acid base pair reaction, acid base reaction, in a reversible acid base reaction, so two acids and two bases are present. Two acids and two bases are present. Two acids and two bases are present. Sir, here if you observe carefully, sir, one acid that is converted into base, here the base is converted into acid. So in this equilibrium reaction, a strong acid after the dissociation of H plus or after the donation of H plus, that is converted into a base. A strong acid can form weak base, a strong base that can be formed weak acid. So that we have to discuss here. So that only we are calling conjugate acid base pair. Conjugate acid base pair. Conjugate acid base pair. The acid base pair, the acid base pair which is differ by only one proton is called conjugate acid base pair. Conjugate acid base pair. Conjugate acid base pair. Sir, for example, if you take CH3COOH, then CH3COO minus, Sir, both. Here it is a weak acid. That will be converted to a strong base. Now I told in the reversible acid base reaction, weak acid can produce a strong base. Strong base can produce weak acid. Understand all of you? So the reversible reaction it happens. So whatever it may be. So one is acid, one is base. Both are differ by only one, that is H plus ion. The acid base pair which is differ by only one H plus ion, such type of both acid bases we are calling conjugate acid base pair. What we are calling? Conjugate acid base pair. So then second one, HCl converted into Cl minus. So it is a strong acid. Then it is a weak base. Weak base. Acid produces base. In case if it is strong, it is weak. So it is weak acid, then produces strong base. Weak acid produces strong base. Strong acid produces weak base. That is the logic here. So these two are conjugate acid base pairs only. Sir, for example, one more, HSO4 minus, then SO4 minus 2. Sir, it is donating H plus ion. It is dissociating. This capacity is donation of H plus ion. Then here it can accept the H plus ions. So it is acid. It is base. So acid base in between only H plus ion is there, that we are calling conjugate acid base pair. Okay, understand? So these are here one of the logic that is HSO4 minus when we are discussing, it is ready to accept a proton, even it is ready to donate a proton. So HSO4 minus act as acid and base according to Bronsted-Lowry acid base theory. That you have to remember it. So now next topic is Lewis acid base theory. Lewis acid base theory. So what are the Lewis acid bases that we have to discuss? Lewis acid base theory. Sir, acid, then base, according to whom? Lewis. According to Lewis, which is the acid, then which is the base. Sir, here according to Lewis, acid is lone pair acceptor. Lone pair acceptor is acid. Lone pair acceptor is acid. Sir, here the substance which has tendency to accept a lone pair of electrons and forms coordinate covalent bond. So this is very important. Look at, these are ready to accept the lone pair of electrons, then form coordinate covalent bond in between the donor and acceptor. Sir, here it is acceptor, then absolute it is a donor, no doubt at all. So lone pair donor is called as base. The substance which has tendency to donate a proton, donate lone pair of electrons, donate lone pair of electrons is called base. Lone pair of electrons is called as base. Sir, one is acid, one is base, one is acceptor, one is donor. Sir, here one of the example I will explain how it can donor, how it can acceptor. Sir, for example, here acid we are taking, that is BF3 molecule. Then base we are calling ammonia molecule, NH3. According to this, how it is. Why BF3 act as a Lewis acid? Sir, because that have tendency to accept a lone pair of electrons. How it is accept a lone pair of electron? Because if you take a boron atom atomic number how much? 5. Then if you write the electronic configuration 1s2, 2s2, 2p1 electronic configuration, right? Then which is the valency cell? 2s2, 2p1. Sir, in the 2s orbital, how many electrons are there? 2 electrons are there. So p orbital, in case if you take, it is px, py, pz. In this only one electron is present. It is actually ground state electronic configuration. In case if you take a excited state electronic configuration, one of the electron jump from s orbital to p orbital. Then here 1 electron. Then here 3 electrons, 2 electrons are present. So boron surrounded by 3 unpaired electrons, 1 vacant orbital also. So boron, so look at boron surrounded by 3 lone pair of 3 unpaired electrons, 1 is vacant orbital like this. So these unpaired electrons only involved in the bond formation with a fluorine. That is why we are calling BF3. So that boron containing vacant orbital like this. So which is having the vacant orbital, that is easily accept the lone pair of electron to form a coordinate covalent bond. So then in case if you take ammonia, as all of you know that nitrogen having one of the lone pair of electron. So this lone pair of electrons, they are ready to donate a acceptors. So then form in between, sir, NH3, then bond BF3 will be form a compound like this. Sir, here we are representing a bond that is dative bond or coordinate covalent bond. What we are calling? Coordinate covalent bond. So that is the reason here it is formed. Coordinate covalent bond is formed. Okay. So now which are the examples for under the Lewis acid, under the Lewis base, that we have to explain. Sir, first acid if you take. Sir, which are the Lewis acids? Which are the Lewis acids? Sir, first one, all electron deficient molecules such as BF3, AlCl3, B2H6, BH3. So all these are electron deficient molecule. All the electron deficient molecules are Lewis acids. Then second thing, all cations and transition transition metal cations. All cations nothing but these also metal cations and transition metal cations. For example, say Na plus Mg plus 2, then Ca plus 2, then Fe plus 2, then Fe plus 3, then Ni plus 2, then Cr plus 3. So all these will come under the acid. So that is the reason we are calling all cations and transition, all metal cations and transition metal cations all are act as Lewis acids. Then not only these, non-metal oxides also act as a Lewis acids. Non-metal oxides also act as Lewis acids. Note it. Third one, which are act as a Lewis acids. Non-metal oxides are acts as Lewis acids. What are those? So for example, CO2, CO, NO, NO2, SO2, NO2, these all are what? Lewis acids. So Lewis acids, non-metal oxides will come under the Lewis acids. Then one more thing, six-step configuration containing, then nothing but atoms having 6 electrons in valency cell. These are also, for example, oxygen, sulfur, so etc. So these all are atoms which are having 6 electrons in their valency cell, that also act as a Lewis acids. So remember, all electron deficient, all cations such as all metal cations and transition metal cations, then non-metal oxides, then atoms which are having 6 electrons in their valency cell, that are act as Lewis acids. So now which are act as a Lewis bases, that we have to discuss. Lewis bases. So first one, all electron rich species. Such as number 1, ammonia NH3, lone pair of electrons are present. Then H2O, lone pair of electrons are present. Then such as C6H5NH2, lone pair of electrons are there. CH3 bond NH2, lone pair of electrons are there in the nitrogen. So these all are electron rich spaces. Even in case if you take CH3 bond O bond CH3, so lone pair of electrons are present. So electron rich spaces, electron rich molecules are all calling Lewis bases. Next, one more point, that is all anions acts as Lewis acids, Lewis bases. Anions, Cl minus, H minus, OH minus, Cn minus, Nc minus, so all these are. Sir, anions or act as Lewis bases because electron rich. Then one more thing, metal oxides are acts as Lewis bases. So for example MgO, then CaO, then Fe2O3, these all are oxides, acts as, so what, Lewis bases. Then one more point, it is the fourth point on this, and then last point in this, molecules, so which are mainly organic compounds, organic molecules, nothing but hydrocarbons, which has multiple bonds, even that also acts as Lewis bases. So for example, in case if we take CH triple bond CH, CH2 double bond CH2. So these are the three acid base pairs, three acid base theories such as Arrhenious acid base theory, Bronsted Lowry base theory, then Lewis acid base theory. How many types are there, how they are expressing, so all these are important topics and important points from the acid base theories. So now just a few questions we will discuss based on the NEET. Yes, look at all of you. So here two questions are there on the board. So one is conjugate base of HSO4 minus is. So conjugate base of particular compound, base is required. So remember that conjugate acid base, nothing but it is differ by only H plus ions. Only one H plus ion is differ. Then one more thing, sir, acid it can donate H plus ions, base it can accept. So your base is required, base accept the H plus ions. Sir, which is accept H plus ions in the following? Sir, one, look at here, sir, SO4 minus 2. Sir, why you are taking SO4 minus 2 only? Sir, H2SO4 if you take in between both, only one H plus ion only is there. But here what had it taken? It is accept the H plus ions. Sir, accept the H plus ions. In case if it is accept the H plus ions, then H3SO4 will be formed. But here what is there? HSO4. So once if it is accept H plus ions, then it will be formed HSO4 minus. So that is why this is the answer for this. Then they are asking conjugate acid of particular compound. So it is a base, acid is required. It is a base, acid is required. Sir, base what can do? Base what can do? Base always releases H plus ions. So it is acid, now it is a base I told. When it lost H plus, then what will be formed? This will be formed. That's it. So here both cases, in the here and here, HPO4 minus 2, PO4 minus 3. In both cases, only H plus is differ. It is differ by only one proton. Even this case and this case also differ by only one proton. So that are we are calling conjugate acid base pairs. Understand? Yes, I hope it is understand. We'll continue in the next chapter, next topic, lecture number 6 or 7. Then we'll discuss now.